That's right. We're doing geometry. I don't know. I thought that would be funny. Okay. Just going to go through some refreshers for this first lesson in points, lines, and planes. Not going to cover everything in detail, but hopefully just kind of a, like I said, a summary. Um, so let's go through the notes part real quick. A point. A point is a single location, so it has no like depth or width. There's no size to it, and you always use a capital letter to name it. So that's like point A here. A line is basically if you connect an infinite amount of points together, and it goes on infinitely, like we just said. So note the arrows on both ends. That means it keeps going, it keeps going. The naming convention, any 2 points, so like I could say that's line X, Y, and I could put the little line with the arrow on both sides over top of it, or lowercase script letter. Collinear and non-collinear, that's a word that might start to throw us, or 2 words, I guess. The idea of collinear, think about if something is coexisting, they are both like together. Co meaning together, they are both on the same line. Just opposite then, non-collinear would be points that do not lie on the same line. Must be at least 3. Speaking of at least 3, need at least 3 non-collinear points. So if they were in a straight line, then we don't know that it's a plane and not a line. So in this case, over here, think of a flat surface. I always like to kind of in my head when I'm talking about planes, picture like a flat piece of paper. There's no measurable like thickness to it, but you can like rotate a plane like you could a piece of paper, kind of like down here. We talk about intersecting lines, so that happens at a location or a specific point, like point P in this instance. Planes intersect at a line. So notice they use the lowercase k script there. I think you can hear the dishwasher going. That's all right. But those two, think like pieces of paper. They cross and it forms this line here. So you kind of have to, in your head, kind of picture that in 3D. Not going to go through all this, but just a couple things. Collinear points, it says name 4, so you would need to find somewhere that has 4 points on a line, maybe like right here, and you would name those points. Something that sticks out to me is part D here, another name for line Q. So I see that lowercase script right here, but remember we could also call that line JK or JL or KL. Let's look at a plane. Again, you kind of have to think of a 3D surface, so like looks like BC or line K is, think if you have a piece of paper, and I thought I had one right in front of me. Think if you have a piece of paper and you jammed your pencil up through it. That's kind of what's going on right there. So like the intersection of plane M, so script capital letter, or you could use A, D, F, 3 points that are on the plane, and line K, that would be that point E right there. Okay, let's keep going, or let's look at C real quick down here. Are points D and E collinear or coplanar? Uh-oh. Okay, I think we're good. My computer wanted to update. Another, or which one are we on? C. Are points D and E collinear or coplanar? So notice these separate planes here. So they are not on the same plane. They are on this same line. I believe that's a script L. If we knew there was a third point here, and from the way I'm looking at it, we don't, we could say they're collinear and one that's just not shown, but based off the information given, doesn't look like that. Let's come over to delta math. So this is something I use a lot. We talked about naming conventions. There's multiple letters here, so for a line you just pick 2. Same thing. Naming planes, make sure you understand that it's the like highlighted one. So that's this like slanted surface. If you're thinking about it as a 3D, like a box, it's going corner to corner. You need to use 3. What else we got here? Naming. This name 2 planes that are parallel. So remember, parallel, like think lines, don't cross. They go on forever. Parallel planes, same thing. They extend forever without intersecting. And perpendicular would just be the opposite. They would need to meet at a 90-degree angle. So think if you had a cardboard box in front of you, it's what 2 sides make that corner, would make them perpendicular. Okay, hopefully this helps for points, planes, lines, anything else I talked about for 1-1 here. See ya.